Okay, hi guys, welcome back. So we will continue our programs on branching. In the previous session, we did some area and perimeter of rectangle, Heron's formula, quotient, and remainder of a number. So as we progress, we do more programs. That the main motive is, as I already told, to improve the programming skills, right? So the next one, before getting into these two, let me do these two and then come back here. Okay. So next one we're going to see is the roots of a quadratic equation. So what is a quadratic equation? A quadratic equation, we would have already known that, right? A quadratic equation is something ax square plus bx plus c is equal to 0. So the question is more of finding the roots of a quadratic equation. So mathematically speaking, a quadratic equation is a one which touches the x-axis in a graph, right? So ideally, if the roots are real and unequal, it touches at 2 points in the x-axis of a graph. Okay, so ideally you will get two solutions for a mathematical stuff. Okay, and if the roots are real and equal, it's going to touch 1 point, and both the numbers, the same number, will be the two solution for us. And there could be an imaginary case which we call as a discriminant. So we say b square minus 4ac, right? So a, b, c are the coefficient of the equation here, and discriminant is b square minus 4ac. So the roots of the quadratic equation formula is minus b plus or minus. So you need to do plus 1 times square root of d, the discriminant, okay, divided by 2a. Okay, so this one is x1, and the other root is same way, but the only difference is this piece, minus b minus. So you would have found the roots in many methods in your school, right? In your lower classes, maybe x square plus 5x plus 6 example. Okay, so we would have done with the factorization method, x plus, so if you guys remember this one, x square plus, we would have done 3x plus 2x plus 6 equal to 0. Take x common the outside, you will end up in x plus 3 plus 2, and then x plus 3 equal to 0, and then you will get x plus 2 when you take x plus 3 common the outside. These are like mathematics we did in our school in lower classes, right? So finally the solution is x equal to minus 2 minus 3. For any type of equations, there is a formula for that to find. So that's what this is all about, minus b plus or minus square root of b square minus 4ac. So in a computer, when you feed into a computer, the formulas makes more easier for the program to run and get the answer instantly. So what if the square root of d becomes negative? That's quite possible. So in that case, we call it as the roots are imaginary. So a little bit of math class here, right? Okay, so we will convert the same requirement into a program. Let me create a program quite quick. And as usual, I will save this as, go back, let's create this quadratic equations. Fine. So you need to get an input from the user. So what are the input you need to get? You need to get A, B, and C. So let's assume we get everything as integers for now. Okay. And there could be equations with decimals also, like 0.5x square, but that's fine. So assume we convert everything into a proper integers. Okay. Yeah, any equation you multiply, you can multiply on both sides because the right side is 0 to get into a proper equation. So that is a different story, right? Altogether. Now, you get three inputs. So let's make sure you get A equal to int of, make it a little big screen, input of, enter the coefficient of x square, right? And what's going on? Oh, I'm sorry. Enter the coefficient of x square, and then b is equal to int of input, enter the coefficient of x, and c is the constant term in the equation, right? Input enter the constant term. So we talked about discriminant, right? So b square minus 4ac. So let's do that. So b square is nothing but multiplying b two times. Don't forget, do the brackets properly. Minus 4 times a times c. So now you got the discriminant in our hand. Okay, so it's good to have small d, the naming convention. Now let's find if d is by any chance is less than 0, correct? So there is no use if d is less than 0. When I say no use, there is no roots actually. So you can simply print the roots are imaginary. Okay, and if d is equal to 0, so that means what? The both answers are same, right? So minus, so you just need to simply, so you see this equation, what if happens if d is 0? Yeah. So this part completely becomes 0. So all you need to do is minus b by 2a is the answer for both the roots, correct? Because the this part becomes 0, the both x1 x2 both are same, minus b by 2a. You don't need to worry or do much thing here, right? So you could say the result equal to, or you could say x1 is equal to minus b divided by 2 times a, right? So and you can simply print the roots are real and equal. That's enough. And else, so else is the case where d is greater than 0, correct? So that's where you need to apply the formula more deeply. Minus b plus d, right? For one case, minus b, d square minus 4ac divided by 2a, divided by 2 times a. For 1, x2 is equal to minus d divided by 2 times a. Okay, and finally you can print the roots are real and unequal, and you could print the roots x1 colon, yeah, x2, right? Let's try to run this with the input, basically x square 1. So I'm going to run for x square plus 5x plus 6. Yeah, so see the roots are real and equal, minus 2 and minus 3. Let's try to run for another input, like something like x plus 1 the whole square. So I think for that, x square plus 2x plus 1, right? The input x square x plus 1 the whole square. So the answer will be more of minus 1, right? So x square plus 2x plus, yeah, x square plus, yeah, 2x plus 2 maybe. So when you expand this, a plus b the whole square is a square plus 2 times a times b plus b square. So x square plus 2x plus 1. So 1 2 1 is the input for the next thing. Yeah. 1 2 1. So as we say, roots are real and equal. The answer is minus 1. Okay. So to think about um yeah, something on imaginary roots, it's quite possible to test it. Okay, so which is similar to x plus 5 the whole square. Now there are some equations we can certainly test. Let's find out. I'm not getting something like that. Imaginary quadratic equation, imaginary roots. Yeah, some trigonometry imaginary roots. You could say this one, x square plus 4x plus 5 equal to 0. right? It doesn't even touch here. So this falls under completely imaginary roots. We can take this 1, 4, and 5, right? 1, 1, 4, 5. Okay. The perfect leads are imaginary. So all cases we tested. So important, guys, as a when you start learning programming, right, in your early days, make sure you test each and every case, right? So the if else. So you should not test only, okay, so this piece is working, I am good. No, you should test every case and then make sure the program is pretty good. Okay. So next we will move forward with maximum of 3 numbers. Okay. So the program is so simple, right? So I mean, the question is so simple. So the user enters 3 numbers, one after another. So if the user enters the numbers like 10, 5, the 10, 5, and then followed by 15. The maximum of 3 numbers is 15 here. If the first input is 20, the maximum of 3 numbers is 20 here. So basically, you will get 3 numbers from the user, and you will find the maximum of the 3 numbers. So I will do an approach where many people will think of, and then another approach which is quite easy, okay, and very simple code also. Let's do that first. Maximum of 3. Let me save this here. Sorry. Yep. As usual, you need to get 3 numbers from the user. So the first number, y is equal to int input of. Enter the second number, z is equal to int of input of. Enter the third number, right? Now let's see how it goes. So the natural tendency is doing this, right? If x is greater than y, maximum of 3 numbers, and y is greater than z, so you could say print maximum is x. If y is greater than x and y is greater than z, print maximum is y. And finally, you could say L. You don't need to check the final part basically, because if that is the case, then Z is a maximum for sure. Okay. So if you run this program, okay, I forgot that colon here. Okay. What else is the problem? Oh, okay. Oh, I forgot the double quotes. So see here, it reports the invalid syntax. Fine. First number 10, 4, 5. So what went wrong here is if x is greater than y. Oh, here the condition is wrong. So x is greater than y and x is greater than z. Y is greater than so this is a normal way. Let me say I put that condition wrongly. Then let's go 10, 4, 5. Maximum is 10. Right? And then I run again to see 12, 21, 3. Maximum is 21. Why I'm running is I'm making sure the maxes occur in all 3 possible locations, right? 12, 24, 23, 45, maxes 45. So it's okay. The program works. Can we do better? Yes, that is always a possibility here. You don't need to check like this everything, right? So there is another way. We don't need to print and do all this stuff. So one more way is you start the program by assuming who is the maximum value. Max e is x, right? And then you can very well check if you are maxi, whatever you assumed, okay, whatever you assumed by any reason is wrong. That means that whatever you assumed is wrong. That maxi is less than y. So y is greater. So your assumption is wrong. You update your maxi with y. Okay. Again, if maxi is less than z, you update your maxi with z. And finally, print maximum is maxi. So you don't need to put those and conditions and everything with this approach, right? So what is improved here? You are assuming with the first number being maximum, and if your assumption is wrong, then you're going to update. You're going to check that with y, and if your assumption is wrong, you're updating your maximum. And again, you're checking with z. If that is wrong, your assumption is updating with z. It is basically to find the maximum of a set of numbers. You compare the numbers, the next number, the current number, and the result can be compared with the subsequent numbers. That's the idea behind this, right? So say for example, if x is the maximum guy and y and z are lesser than x, okay, the maxi will remain at x. The conditions will not go into this if conditions. So the first number being maximum for that use case. If the second number entered is maximum, which is y, in that case, whatever you assume will be, the code will go to the if condition. The maxi will get updated to that particular number, and then that will be maximum. If the third number is the maximum of all, like strictly increasing order, the code will go to both if conditions. Maxi will keep on updating, but while you're printing, you will have the updated result of the maximum. Let me quickly run this again for the input, whatever we just ran. So answer is 45, right? We run again to check the first guy is maximum. Sorry, second guy may be maximum. Here we go. Final test case. I need to run the first guy being the maximum. Right. Okay. So yeah. So keep practicing, guys. Okay. So these type of programs, I will continue in the next session for more programs. Right. So we will keep learning. Thank you.